Introduction. Over 1 million earthquakes a year can be felt by people on Earth. Large earthquakes and related effects rank among most catastrophic environmental events. Both tectonically active areas of lithospheric plates interactions along their boundaries and intraplate fault displacements are responsible for rupture-yielding seismic waves that shake the ground. Devastating effects of the earthquakes that occurred during the last decades underlines the necessity of a multi-hazard approach regarding the subsequent effect of the tremor waves, such as tsunami waves, Sumatra, Andaman Islands, 2004, NI Japan 2011, soil subsidence and major accidents at nearby chemical facilities, Turkey, Kocaeli, 1999, explosions at petrochemical and nuclear plant, after failure of the cooling system due to power failure, following the 10 meters tsunami wave, NI Japan 2011, submarine landslides, northern coast of Papua New Guinea, 1998, or landslides and soil liquefaction, earthquake lake at Sichuan, China, 2008, Christchurch, New Zealand, 2011. The multi-hazard concept represents a new direction of research in an integrated manner, with applied global implications. The frequency of the disasters appears to increase in the last decades, figure 1,2, and the communities became more vulnerable to the natural hazards, generally due to the complex aspects generated by increased urbanization, land planning and environmental changes. The uncertainties involving the relations between different components of the surrounding environment made more difficult the investigation of each category of natural hazards. Consequently, it is necessary to study groups of hazards, not just a single case, and the interaction among them in order to have a clear view of the internal processes and causative factors of the disasters. From this point of view, the disaster seems to be more internationalized, due to global factors which interact and affect the population and the environmental factors. Problem statement. Recently it became relevant that, despite frequent large earthquakes, several countries located in prone areas didn't have strong building codes and many houses are built out of mud bricks and unreinforced masonry, which do not stand up well to earthquakes. Mud brick didn't resist to the earthquake stress and too heavy tile and cement roofs generally collapsed into many houses. Other factors contribute to the severity of a quake, but earthquake-resistant buildings can make a huge difference in the number of damages. As a result, casualties and damage are much higher than similar earthquakes elsewhere in the world. Therefore recent major earthquakes such as Gujarat, India, 2001, Bam Iran, 2003, Sumatra, Andaman Islands, 2004, Kashmir Pakistan, 2005, south of Java, Indonesia, 2006, or Sichuan, China, 2008, led to heavy human casualties, compared with other similar earthquakes all over the world. The same magnitude earthquakes, for example the Northridge quake in Los Angeles in 1994 killed only 57 people and in Kobe, Japan in 1995 a similar quake killed about 5,000. Another example could be the earthquake magnitude 7, from Haiti, at Port-au-Prince in January 2010, with almost 220,000 casualties compared with a similar earthquake in the next month, in Chile, magnitude 8.8, 500 times higher than the previous one in Haiti, resulted in less than 600 casualties. In case of major tsunamis, which cross an entire ocean, or so-called tele-tsunamis, i.e. the greater earthquake ever recorded by instruments, with a 9.5 magnitude, in Valdivia, Chile, 1960, which produced damage in Hawaii and alarm in Japan, it became obviously the globalization of the subsequent effects of the tremors. They can reach any coastal areas all over the world, not necessarily earthquake-prone areas, and request dedicated building codes. A similar effect took place following the recent great earthquakes at Sumatra, Andaman Islands, 2004, 9.1 magnitude, with damages 1 mile inside the affected coastal areas, with a maximum height of the tsunami wave up to 30 meters, or the recent NI of Japan, 2011, magnitude 9, where tsunami waves inflicted severe damages 9 miles inside the coast areas. The recent catastrophe in Japan exceeds the worst-case scenarios previously estimated in prevention measures, especially at the nuclear plants. The maximum possible height of a tsunami wave was estimated at 6 meters high, whereas the height of the wave reached 10 meters, the maximum recorded height was 23 meters for the NI of Japan.